Hey guys, welcome back to Computational Biology with Python. In this video, we're going to finish up our sequence annotation section and learn a little bit more about modding and changing annotations. So let's jump in. Okay, so for this next part here, we're going to go back to using our downloaded NC GenBank file. So what we're going to do is we're going to do record equals seq io.read, and then we're going to do this nc underscore 005816.gb.txt is how I have it saved. Now we call it a GenBank. You might have this already. No, you probably have replaced this variable since we've loaded it last time, so it's best to run it again. Now if I run record, you can see that we have our GenBank file. We can do the length of the record. And so this is a bacterial or a circular genome, this 9609 GenBank file. So keep that in mind. Let's look at the length quick of the features. So we have 41 features, just like we had before. And if we do this records.dbxrefs, so the database records for this, not records. You can see we have like the project number from NCBI. We can also look up the record annotations and keys for this. And you can see all the different things we can pull up, the molecule type, the topology, the date, the assumption, sequence variation or versions, etc. Okay, so we're saying this all because since this is a circular genome, who's to say what the start and the stop is, right? Who's to say that this is the very first part of it, because it's a circle, it's endless. But we can actually shift that. So we can do, say, shifted equals record, and we're going to say 2000 to the end, and then add the beginning, record everything through 2000. Shifted equals, not minus. Okay, so now if we look at shifted, we should see that we start with GATA as opposed to before. So we're starting at position 2. Previously, we had it numbered as 2000, and we're going all the way to the end again. So if we look now at the length of shifted, we should have the exact same number, 9609, just like we had up here. So we haven't changed anything about the information in there. We just changed where we start in the circular chromosome. So imagine we started at the top before and read all the way around. Now we're starting over here and reading all the way around. So if somebody else, if you have a different file that somebody else is using that your sequence, like if you and another person both sequence the same circular chromosome or the same plasmid, your records might look different based on where the sequencing started, right? Or where it was put together to start. So you can shift that. So there is a caveat to this. If we look now at length shifted.features, you can see we only have 40, so we've lost a feature. So if we do shifted annotations keys, we see that we just have molecule type now. And so this is because it doesn't want to carry on these annotations if they're not correct. So it's rather safe than sorry by getting rid of them, right? We can also look at this dbxrefs of shifted, and you can see it's nothing anymore. So this was the reference that we had above, this project 58037. So it's cautious what annotations are preserved. And so if you start using improper annotations, it can cause problems, especially if you put your data onto like GenBank or something that, you know, multiplies other people that use your sequences. So if you want to keep the database cross-reference or the annotations dictionary, you have to do it like explicitly. So we'll do that. Shifted dbx refs, and we're going to say it's the same as the record dbx refs, and we're just going to say everything. So now if we look at shifted dbx refs, this should be refs. Let's run that again. There we go. And so we've added the project back to it. And we can also do shifted annotations equals record annotations, and we can do copy. So then if we look at shifted annotations, the keys or like the titles of the shifted annotations, you should see that we have all the things that we had before. So you should probably change the record identifiers since NCBI references refer to the original unmodified sequences, as that's why it's cautious. So you probably shouldn't be doing this a bunch unless it's just for like your annotations. So let's see. Let's do so let's look at reverse complement again. So let's do record equals sequio.read. Actually, so we still have record, right? Let me double check. Okay, so we're just going to use record from before. So we're going to print %s, %i, 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 close that, and record ID, length of record, then record features, so let's put a period there, features, length, record, dbx refs, length, record, annotations, and then close that. Oh, there should be no comma here. Okay, so for this, what we just did here, I want to explain this real quick. So we said print, and what these are, it says print the first value as a string. That's what %s means, a string. So like letters, right? And then these 4 %i's mean present the next 4 as integers. And it says, and do that to our record ID. So our record ID is the first one, so that's the string. And then the length of the record features, the length of the record dbx refs, and the length of the record annotations are all integers. So you can see that from our, for our record, the NC 00581 or 5816, we have the name of it, and then we have, it's 9609, long, it has 41 annotations, it has 1 reference, and it has 13 annotations, or sorry, 41 features and 13 annotations. So now the big question is, okay, if you run reverse complement on this sequence, does that keep everything? So you have all these annotations where the gene starts and the gene ends, and you know, you might have promoters or something like that indicated on here. if you have the reverse complement, that sequences change, right? It's all the complementary ones, and it's in the opposite direction. So what happens is we'll see RC equals record reverse complement, and we'll call this, we're giving it a name, and we'll call it testing. So if we run this, now we have a reverse complement. So we'll run this real quick so you can see that we have, it's just backwards of the same thing. And then we can do print %s for the sequence, and then I, and run this. So we're doing integers, so we're just doing the exact same thing, but on the reverse complement. So RC ID, length, RC, length, RC features, length, RC DBX refs, and then length, RC annotations. Okay, so now if we run this, you can see that we keep our length, obviously. We've renamed it to testing. We keep our length. We keep our features, but our reference is now no longer the same because they wouldn't match up if you were to search. And our annotations are different. And so yeah, so this is by default to make sure that, again, you're not creating duplicate IDs with sequences you've manipulated, because if you're going to compare things, someone might not know that you did the reverse complement and then you changed the origin and all this stuff, and then if you were to send that file to somebody else and they say, oh, this record ID is NC0 blah blah blah, and it doesn't match at all, and they're like, what's going on? And then they spend, you know, a year of their life trying to figure out why their analysis isn't working. So this is done purposely. So I think that is it for annotations. Kind of got to play around with some GenBank files and kind of see what's involved and how you can manipulate them. And you can, oops, oh, where'd my camera go? I'm invisible. Now I'm here. Okay, well, I guess we're doing our farewell on this camera because my camera isn't working up there. So this is how you end, or how you can manipulate these GenBank files and things like that. So I hope you enjoyed the video. If you're watching on YouTube, please hit like, please hit subscribe. It helps me out. We're gonna move on to another Seek. Let's see, what do I have in the pipeline here? Let me pull it up. We are going to move on to, well, I don't know, where'd it go? Well, I'm not gonna sit here and make you up. You'll figure it out in the next video, like I'm looking up to the other camera. Thanks for watching. Hit like, hit subscribe. I'll catch you in the next video.